to get to our private members. And I'm sure you can think of all sorts of jokes about that. As a way of remembering that, go for it, okay? But private is private. And we notice that this private member can be only accessed by things that are part of the class. Classes, in reality, are made up of private members and public members. If, on the other hand, we made this public statement that we have here, change it into private. So now put element and get element are private members. What do you suppose is going to happen down here when we do this line? Syntax error, can't get to it, not allowed. Shrink wrap is up, the border is up, boundary is up, you can't get there. Clear? Okay. So you want to think about that split between private and public members. And since we're talking about that, it's only in this instance in which the public members are all functions and the private members are all data. Doesn't have to be that way. Doesn't have to be that way, but many times it is. Question?
So if you remove that public,
Yep.
the put tell and get tell are still public.
If I take
They
the
would be
word
private
public
by
out of there,
default.
now all of a sudden I've got
Everything's
nothing but
private?
private members.
Okay.
Now private data members and private member functions in a class are useless. If everything is private in the class, it says nobody can get access to it. It's kind of like having a computer without a display screen and without a keyboard. Useful? Not very.
Function you can't get to.
Functions you can't get to, programs you can't put data to it, you can't get data out of it. Okay? That's how serious it is.
So wherever you put it, everything that falls below it will be private unless you okay.
And you can, by putting the word private or public in as you go down, you can change them back
Okay.
and forth. However, if you do that, you're going to confuse 1,000 people. Everybody who
yourself.
tries to read it. The standard is put all the private stuff up top and then public stuff after that. Okay. When we talk about a class's interface, remember we talked about the string interface? The interface to the string, this is what we're talking about. This is its public interface. This is the only way I can get to that array. It's its interface. Okay.
So the array is private, but its interface isn't.
Correct, if we make it public. It's not an interface if it isn't public. It's like saying, well, I've got a keyboard, but it's not connected, it's unplugged. Okay? All right. So when we do something in here, put element, and this J was out of bounds. It was 140. Somehow it got to be 140. I don't know. It got there. What's going to happen? We're going to come to this. Well, let me back up a second. What happens when we actually hit that line of code? In memory, we have instantiated a copy of that class, the class array, safe array. It has a copy of the array and a copy of the code. So when we say this, SA1, I'm referring to that specific object in memory, and I want to invoke the putL method, the putL member function. Method, member function, same terms, same thing. I want to invoke it, and I want to pass those two parameters to it, just like we've been doing all along. parameter passing. So we come in here, and at this spot, put L gets the first parameter, n, whatever is j was, and int L val. Okay, so notice that they are both passed by what? Reference or value? Passed by value, right? They're both passed by value. And so we come in and we hit this if statement. Is there anything there that you couldn't write otherwise? Every time you did some kind of an operation on your code that you've written so far with an array, couldn't you always check the bounds? Sure you could. Right there. And what would happen if you did that every time you did a change to the array reference? You had an if statement before you made it. You'd get really sidetracked, wouldn't you? You have this thing, let's change the value of j and reference something. Oh, but before I do that, I have to check the value of j. I'm going to get sidetracked right there. As I'm reading a programmer, I'm reading the code, and I'm looking at it and saying, what's this if statement? But with this, we hide all of this in the class definition. So I don't have to think about it. I don't have to think about it when when I am the consumer of this safe array. Clear? So this code certainly does run, and if it passes the test, it'll do the assignment. If it doesn't pass the test, we get an error message, do whatever you want to do, shut the program down, which is what this does, with an error code of 1 in this case, or just continue on, just pretend it never happened. That'd be a cool thing, right? Have a check to see if you're out of bounds, but if you're out of bounds, don't do anything. But certainly that's an option for you. All right. Is that clear? Wednesday, I'll continue this discussion on building classes, and we'll look at how we can separate them, how we sometimes need to separate those into multiple files. Okay? We'll see you Wednesday.